Hello and welcome, I'm Johnny and you want to test your SvelteKit app with Vitest. The most popular framework to test JavaScript is Jest, and I love Jest, but its biggest drawback is that we have to configure it separately in order for it to understand the files we're testing. If we're using unreleased JavaScript features, we may need to bring in bubble Jest. If we're using TypeScript, we may need Jest. If we're importing SVGs, we'll need to stub them. Bundler configuration may be the most unpleasant part of web development, and we have to do it twice if we want to have this sort of test. What's worse, the separate configs mean we'll have less confidence in our test to begin with, because it'll be on us to ensure how we're configuring our tests accurately reflects reality. That's the drawback Vitest aims to eliminate. If you're using Vit as your bundler, which you are if you've gone with SvelteKit, Vitest can run with the exact same config. It will also use Vit to transpile your files for your tests, the same way as Vit would transpile your files for the production deployment. So, we've got tests that are more in sync with reality, with less config to maintain. It's not zero config though when it comes to SvelteKit, so let's get to it and set things up. Let's bring in Vitest with npm install dev dependency vitest, and while that happens, let's say we want to create something like this revenue dashboard screen, and focus on these elements that show some formatted currency numbers. Let's start by writing a helper method to format currency. Let's create a lib format currency ts file and write a named export with the same name that does nothing. We do know that it will be receiving a value as an argument. That value is going to be a number like 1, 42, 5 billion. Cool, let's write our first test. Let's collocate a lib format currency.test.ts test file. Here we need to specify what our code does, what it does, and what we expect to happen. So let's bring in it and expect from the Vitest library we just installed, and now we can say that our code, it adds the # before the given number. Then we pass a fat arrow method, and in its body we add all the setup and expectations we want. For this test, let's say that the result of calling our format currency method with 1, we expect the result to be #1. 1 pound. And now we can go to our package.json and specify our test script. All it's gonna do is run vitest. So now we can go to our command line and execute npm test. We can instantly see we've got a failing test, and this will run vitest in watch mode, so it will keep rerunning every time our files change. You can see this rerunning every time I save, and you can't really feel it when it's just a single tiny test, but another reason to use Vitest is that, much like Vit, it is indeed super fast. So let's go to our implementation, and the simplest way I can think of to make our tests pass is to literally hardcode 1 pound here, and if I save, we see green. The test passes. People sometimes get upset when I do this, but hardcoding the solution is the first step to test-driven development. So if you've got TDD in your CV, you better believe I'll want you to start like this. You gotta start with the simplest solution you can think of, until you've got a failing test that forces you to increase complexity. Or you can say you don't do TDD, that's also fine. Anyway, let's get us back to red. Let's change this to result A and introduce our result B, which will be what happens when we pass 42 to our method. We expect that to be #42. Cool. We're in the red again, we can go back to our implementation and finally use the given value as a placeholder in a template literal, and back to green. At this point, it may feel like we're done and we've managed to set up Vitest with zero config indeed, but SvelteKit does some magic that Vitest is not aware of. You see, the way Vitest works by default is it will look for a vit config ts file. However, there is no such file in a SvelteKit project. There is a svelte-config.js, which exports a config object that can have a vit property. The object we pass here will get merged with SvelteKit's own options, which do trivial things like alias the lib directory to $lib, and super important things like configuring how to parse .svelte files. But Vitest can't see all of this setup by default, and the most obvious way to showcase how that's a problem is to create a Svelte component. Let's do it. Let's say we've got a currencystat.svelte component. In its script tag, we can say it takes in a value, which will be a number, and it returns that value inside a div. But it returns it formatted using our new utility method, which we import using the magic .lib path alias. Let's quickly create a route to render this component. Split screen the browser window on the side here to see that it does indeed work IRL. But now let's write a unit test for currency stat. So let's create a currency stat.test.ts. Let's import it from vitest again and say it displays the given value formatted as currency. And if we save with no expectations or anything, you can see we have passing green tests. But the moment we import our currency stat component, we can see the test flipping out because of invalid JS syntax. Again, that's because our vitest is currently using vit in a different way than our SvelteKit app. So the situation we're in really is the problem with Jest we mentioned in the beginning. Real life is using one config, while our tests are using another. The way to use the same is by bringing a library called vitest-svelte-kit. So let's npm install dev dependency vitest-svelte-kit. And now we can create a vitest-config.js. Import extract from SvelteKonfig from vitest-svelte-kit and default export the result of calling that method. This will extract the vitest config we want based on what our SvelteKonfig.js has in it. So if we start our test process again, you see it passes. However, we're still not done. Remember, we're not actually testing anything here, and there is a couple more libraries we'll need to bring in to test Svelte components. Now, you can test Svelte components without bringing in svelte-testing-library, but it is quite unpleasant. And I'm a big fan of anything testing library anyways, as I do believe that it does help us write better tests that avoid testing implementation details. So let's bring in svelte-testing-library. Back to our terminal, let's npmi dev dependency @testing-library svelte. And now in our test, we can import render from testing-library svelte. So inside our it block, we can render our currency stat component with some props. Let's go with a value prop of 1 to 3. But immediately the test will crash because document is not defined. Vitest is a node process, it doesn't run on the browser, so we gotta bring in our own simulated browser environment if we wanna test things like UI, like our Svelte components. Vitest recommends jsdom or happydom for this. Let's bring in npmi dev dependency jsdom, which achieves nothing by itself, as we also need to specify in our vitest config that we wanna use the jsdom environment. But how do we do that? Where? Well, the where can be in vitest-config.js, but given we're extracting from the Svelte config, it's probably best to go to our SvelteKonfig.js and in that vit key add the test key, which can take all of our vitest configuration, and specify environment jsdom. If we restart our tests now, document will be defined and our tests will finally run as expected. So if I were to fake TDD this component, let's say we started by using the value unformatted. And in our test, render returns the handy testing library selectors. So with this structure, get by text, and use it to try and find #123. But this fails and we get the helpful DOM printout to see it's because we've rendered the value without the # in front. So if we go back to using our format currency method, our tests are happy. At this point, we are indeed testing SvelteKit with vitest. We don't need anything more really, but if you come from Jest land, you may be used to it and expect being globally available, so you may use them without importing them. And if you've used testing library before, you may have enjoyed the extended matchers like to be in the document. We can have the same experience with vitest. We can pass the global's true option, and to keep TypeScript happy, we should also install the @types jest to let it know we've got the Jest compatible matchers available. As for the extended matchers, we can npm install dev dependency testing library jestdom, create a source setup-tests.ts file, and import testing library jestdom extend expect in it. This will overload the expect global with the bonus matchers. All we need is to go back to our test config and say we've got a setup file for you. It's in source setup-test.ts, and this can be an array, that's why the key is plural, but that's by the by. The point is we can now use things like to be in the document. which I rarely use to be honest, but methods like to have value and to be checked are very nice indeed. Speaking of things that are nice, there is a handy VS Code plugin for Vitest. If we bring that in, we can see the test feedback right beside the 8 blocks, which I always enjoy. However, it doesn't have my #1 feature, which is rerunning the tests on save. You've got to manually trigger them, which is fair enough. There is an open issue for it. Maybe someone can help. Alright, one last note before getting back to TDD-ing. If you're using TypeScript, you may get this error. As it stands, SvelteKit sets up TypeScript by creating a tsconfig.json, which extends one generated in our SvelteKit directory. However, that directory only gets created if we've run npm run dev or npm run build, and it's of course not committed to source control, so if you've just checked out a SvelteKit repo, this won't exist. Running either of those commands resolves that problem, so keep that in mind if you've got your continuous integration running your tests. It will fail if you haven't done either, so what I've done in my GitHub action is run the build command first and then run my tests. Maybe not the most elegant thing to do, maybe you're supposed to have the build step separate and reuse the artifacts or something, but hey, it works, so good enough for me. Cool, with all of that out of the way, we can finish implementing our spec. But the question is, should we be unit testing the format currency method or the svelte component, or both? Should we just be testing the dashboard component that will be showing all 3 formatted numbers? Or even should we be testing the dashboard page with a tool like Playwright or Cypress instead of Vitest? The answer is the usual, it depends. You can argue for any combination, but I do think having essentially the same tests for the currency format method and the currency stat component would be silly, so only test either of those. And as good as testing library is, testing a component is clunkier than testing a plain old JavaScript method. So I'll keep my spec here, I'll only thoroughly test currency format. If your stat component has more complexity than mine and it's the only thing using currency format, maybe you'll want to test on that level instead. On the Vitest versus Playwright or Cypress front, Vitest and Jest and any node test runner for that matter will always be faster than a tool that runs an actual browser. And for that reason, I prefer having my more thorough tests that go over all the edge cases in Vitest. Unless they're testing a fundamental browser feature that is poorly simulated, like drag and drop and file uploads. And in any case, you do need some more integration-y functional tests to prove you've set the units up correctly. So I would have a happy path Playwright test for the dashboard page that would be checking the page header, the navigation, and whether I'm getting those 3 numbers we care about. However, this is the Vitest video, so let's keep it all in that ecosystem for now. We will test the dashboard component we'll eventually create using only Vitest and testing library. Alright, what remains really is adding commas for readability when the numbers get big. So let's say we're passing in 1, 2, 3, 4. We want the result to actually contain 1, 2, 3, 4. And the relatively new international number format has made implementing this much easier. I honestly think using this is simpler than manually counting digits to figure out where to splice in a comma or whatever. So I will escalate the complexity to this and bam, consider the spec, done. Woo! So now let's create our dashboard component. Let's test it's got the correct heading. And now if I pass it some props for balance, revenue, and pending. Can I find the balance? Can I find the revenue? Can I find the pending? Cool beans, our automated tests say we're done, but we still got the I'd test to go. This is a design only an engineer could love, let's be honest. So let's spend a bit more time griding things up. A bonus if you've got Playwright set up is that it'd be easier to do some screenshot visual testing, but to be fair, I don't think this will ever be automated. Whenever you're implementing something for the first time, when you've got that first pass, you'd need to contact an actual human to verify and get the all clear. Sweet, I can sense the audience retention has been sufficiently obliterated, so a super special thanks to you for sticking around. At this point, you may want to keep going with this video where we set up Jest and React testing library with Next.js, contrast and compare, and YouTube things you'd also enjoy this one. Thanks a bunch for watching, I'll see you around.